What's up, guys? Welcome back to another episode of Mind Something. If you're new here, my name is Jake, and in today's video, I put out a poll recently asking, in addition to GPU mining, what kind of content did you guys want to see? So we got CPU mining coming in first, ASIC mining coming in with a tie for all of the above, and then in a close second is solar. Now, I do plan on building some CPU mining rigs for you guys, but since I can't do that right at this very moment, I thought we'd talk about solar. And in addition to solar, I also want to cover some additional things like wind and hydro, and just kind of show you guys that there are some DIY options for those other things on a micro scale. And, I don't know how large your farm is. You may have a 30 gigahash farm. You may only be rocking 2 GPUs. I don't know. But I think some of these options are going to give you some alternatives to doing solar because your circumstances may be different than mine. I mean, not everybody has an acre or two or a shop or a roof that's conducive to putting solar panels on it. But we're going to cover solar first, and then we'll dive into some of these other things. So before we get into solar systems, I want to talk to you guys about, do you need a backup battery? And the answer to that is most likely no. And I see a lot of people that do mining that have backup batteries, and I'm pulling my hair out trying to figure out, why did you spend the extra money on a backup battery system when it's completely unneeded? Not only is it not needed, it's expensive, it adds a danger to the total system design. It's going to take up some space, it's extremely heavy, and it's also extremely inefficient. So, I just pulled up this article so that you guys have something to kind of look at as I'm talking here, but let's talk about some of the advantages and disadvantages. So first of all, as far as advantages are concerned, if you are not tied to a grid and you live on a mountain somewhere and the only energy that you have is provided by solar, and you're not tied to an electric provider, then yeah, you definitely need a backup battery. But if that's not the case for you, then why are you putting the money into that? So there's a lot of different inverters out there. I think you'd refer to one that can do grid tie as well as backup battery as a hybrid. Now, I personally have just a grid tie inverter, and we're going to cover those in depth. But a hybrid system does give you some options, and perhaps purchasing an inverter that does have that option is going to give you choices later on down the road. But let's just take a look at something in this particular article here. It says how much you save with net metering versus a solar battery. So what they're referring to here is you are essentially going to pay the electric company for that meter that you're using. It's very likely that the meter that's on your house now is not a net meter, and your utility provider is going to need to change it so that they can keep track of what you're producing and what you're consuming. But this article is talking about what is the savings of not paying for a net meter, and your net meter is probably going to run you, let's say, about $5 a month, but they may have additional fees on top of that, maybe $15 a month. So that's not really ideal. It'd be great if they didn't charge you an extra fee for having a net meter, but I think that's kind of a backup plan for them, because let's say, for example, if you produce 5,000 kilowatt hours and you only use 4,000 kilowatt hours, they need to be able to collect something to basically maintain the grid. If they collect nothing from you at all, or they obviously are paying people to go out there and change that meter for you, so they have to recoup something, and that makes sense, right? But it'd be great if we didn't have to pay for it all. Now, as far as not having a net meter and having a backup battery system, essentially what you're doing is you're taking the power that you're producing, you're putting it into a battery, and then you're using all of that stored energy from the batteries whenever your solar is not producing any energy. Now, there's some problems with this. Number one, the conversion between AC and DC is going to create some loss. So efficiency goes down whenever you put batteries into the mix. And then also, you have to make sure that your solar system produces enough electricity to not only cover your usage during the day while the solar system is producing energy, it has to produce enough energy to power your rigs and also power the rigs, or excuse me, charge the batteries so that when there is no sunlight out, you have enough stored energy to run those rigs, which is just ludicrous to me. I don't know why you would overbuild your solar system or the amount of solar panels that you have to store that energy and then convert it back to AC so that you can use it when the sun's not out. Why wouldn't you just produce enough energy and put it directly into the grid, or use 100% of what you're creating, if that makes sense? So I'm kind of going off on a tangent here, forgive me, but it really kind of bugs me when I see people throw away money on this stuff that they don't need. The other thing you got to worry about when it comes to backup batteries is, are you even hooking things up correctly, in the sense that, let's say, for example, your solar system does not produce enough electricity to charge those batteries fully to run all the way through the night until the sun comes back up. Well, what's going to happen if you don't, create something to account for this, is your AC from the grid is now going to charge those batteries. And so now you're pulling AC from the grid, costing you more money to charge backup batteries that you don't even need in the first place. So anyway, I think I've said enough about backup batteries. Let's go ahead and move on to some of these different inverters that you can purchase. So we're going to take a look at GrowWatt's website here. Now, granted, there are a lot of other companies that create grid tie inverters and off-grid inverters, but I've done a lot of research on the subject, and trust me when I say that GrowWatt is probably the most cost-effective solution, and also is a great product. I haven't had mine very long, so I can't speak to the longevity of this particular inverter, but I can say that I did a lot of research and read a lot of reviews trying to figure out which products were good and which ones were bad. And I hear really good things about GrowWatt, so it's something that I recommend. So taking a look at their website here, we've got residential storage inverters, and then we've also got off-grid storage inverters. Now, in the residential storage inverters, what you're looking for is this prefix here, MIN. I'm not exactly sure what the MIN stands for, but I do know what it means is it's a grid tie inverter, and it's not an off-grid inverter. The off-grid inverters are going to start with SPF. So just a heads up, whenever you're hunting these products, if you're not using the links that I'm putting in my description, that's an important feature to know. So the first ones here are the 3000 through the 7600 TL, and then you have the 8200 through the 11400. Now mine is the MIN 6000, and originally I was going to go with the 7600 TL. I have about 7,500 watts worth of solar panels, and this one can output 7,600 watts back into the grid. But when I really stopped and put some thought into this, I realized that my solar panels are used, so there's a good chance that they're not going to produce 7,500 watts. In fact, I'd be lucky to get 90% of that. And my expectations was, on the best days, I'd probably be hitting a peak of about 6,000 watts, and so far that seems to be pretty accurate. So I went with the MIN 6000. This is capable of accepting 12,000 watts, but it can only output 6,000 watts. And if you guys have watched my previous videos, in fact, I'll go ahead and just leave a little link to the first video here. And in that video, I went over a detailed parts list of everything that I used, explaining all of these different features. So I'll let you refer back to that, but I'll just kind of scroll through here so that you can see all of the specs on this particular inverter. So now, if you're going to go with a off-grid inverter, or you do plan on using backup batteries, then you are going to go with the SPF, which is going to look like these here. And you've got your choice from 3,000 all the way up to 12,000. And I'm going to go back to the place where I purchased my inverter from, which is Signature Solar. Now, you won't see this immediately, but if you're on this website long enough, you're going to get this little pop-up here, and it will give you an extra $50 off of your first order. Now, currently, the grow out inverters that they have available are going to be the 3000, the 8000, which is not the MIN inverter. Keep that in mind. This one is off-grid. Let's see here. The ones I think you guys would probably be the most interested in is going to be the 11.4 or the 10,000. And again, the one that I got was the 6,000. I don't see it on this page. We'll back up one page here and see if we can find it. Here we go. So here's the MIN 5000. They currently have this in stock for $729. Here is the 6,000, which is the one that I have. It is currently out of stock, but it is only $40 more for an extra 1,000 watts. Then we have the 3,000 for $459, and looks like these other ones are SPF. So going back to the MIN 11.4 and 10,000, you'd spend $1596 on the 11.4 and $1399 on the 10,000. Now, if you do the math, it is better to purchase two of the 6,000 watts than it is the 11.4. Now, why they've got it priced that way, I'm not really sure, to be honest with you, but to me, the better bargain obviously is to go with the 6,000 and get two of them. Now, one thing to consider also is how many MPPT controllers you get. So on the 11.4, you get 4 of them, and what that means, guys, in case you're not aware, is the inputs on the bottom, how many solar arrays you can hook up at the bottom of this thing. So 4 MPPT trackers means 2 strings per MPPT. Essentially, that's a positive and a negative, okay? So you've got a positive from one string and a negative from another string, and depending on how many solar panels you have and how many watts they produce and how many amps they produce, that's going to determine how many of these MPPT trackers that you need. And keep in mind, you cannot exceed 550 volts, and as far as amps are concerned, you don't want to exceed, I think it's like 16 amps. So just be cautious of that whenever you are looking at solar panels to buy, and make sure that you're within that range after you've series them or paralleled them or however you need to wire them. And if you need help with the wiring, I'll go ahead and leave another link here for you as well. So, you know, as far as purchasing your inverter, things you need to really consider is, number one, do you plan on adding anything in the future? And what's your budget? How do you have enough space for 2 of the 6,000s, or do you only have enough space for 1 of these? Just some things to consider. So as far as, you know, what kind of inverter is best for you, you know, that's all going to depend on your circumstances. But again, if you're not going to have a backup battery system, then the MIN series is going to be the most cost-effective solution for you. And if you do plan on having backup batteries, then you probably want to look at doing an off-grid system or a hybrid. So, moving on, if you want a smaller inverter, there are some options out there, and I'm going to leave a link for this down in the description below. This is a 1,000-watt grid tie inverter that does have MPPT controllers. Essentially, what this does is if you produce power, or let me back up here for a second. The most important feature about something that is a grid tie inverter is that when power is shut off from the electric provider, this shuts off and does not put power back into the grid. That's a safety precaution. And if a line worker is working on the power lines and expecting the power to be shut off, but your solar system is putting electricity back into the grid, that could be extremely dangerous. Now, I do not live inside of the city limits technically, and therefore I didn't have to pull permits for any of this stuff, but I did have to abide by some rules that my electric provider gave me, and one of those rules was I needed to have a DC shutoff switch as well as an AC shutoff switch on the outside of my building. And this again is just a precautionary measure. You should have this built into your grid tie inverter, but they are going to want to see a shutoff switch on the outside just in case. So this particular inverter here is very inexpensive. You can see $109 for 1,000 watts. And as far as inputs and outputs on this thing goes, you'll see here that the DC input range can range from 20 volts to 45 volts DC, and the maximum current is 45 amps. So if you do the math, 45 times 45 is roughly about 2,000. So this particular inverter can take in roughly about 2,000 watts, but it can only produce 1,000. Now, I do not recommend running this thing at 1,000 watts continuous. But let's say, for example, you live in an apartment or you're renting somewhere and you just simply can't mount solar panels to your roof, and you need something to cover your usage for a couple of graphics cards. This would be a really good option for you. You could put out a couple of solar panels in the yard, not have to mount them to the roof, and you could hook up something like this. Now, the way this works here is it essentially has two inputs here. So you've got your positive and your negative from your solar panel, and then the output is just an electrical plug. And let me see if I can find this video here. I think that, yeah, here we go. So you've got your positive and negative on this side, and then you've got your output, which is just your typical standard wall plug. He's got it plugged into something that he can keep track of the output of this thing, but essentially you would just be plugging this into an outlet, and that outlet of course is tied to your sub panel, and that should in turn run your meter backwards if you're not using any electricity whatsoever, or it will just simply go into the grid of your home and will be used up by whatever you've got it hooked up to. Now, an alternative with this particular thing is you could, now I don't recommend this, but you could plug your mining rigs directly into an outlet tied to this thing. Now, the reason you don't want to do that is because you do not want spikes in the power. You don't want voltage drops. You don't want anything like that. You don't want the frequency to drop below 50 or about 60 hertz. And I don't know exactly what range this is putting out power. It is probably somewhere between 40 and 60 hertz. Let's see if it states it in here. Let's see here. So AC output 90 to 140 volts at 50 hertz to 60 hertz. So that is within range, but when it comes to electronics, you don't really want this to fluctuate. And if you can't make sure that this isn't fluctuating, then I don't recommend doing it. But if you can balance that load, then you could essentially plug your mining rig into this thing and power it directly from your solar panels without having to tie it back into the grid. However, once that sun goes down and you're not producing more power than you're consuming, you probably run into some issues. I don't know if I'd recommend that, but I do think that it might be possible. Anyway, moving on, the next thing I want to talk to you guys about would be wind energy. Now, if you live in a place like I do that's extremely windy, then you could take advantage of this as well. Now, my particular inverter does have the 4 MPPT inputs. Or actually, excuse me, it only has 2. So I can have 2 solar strings. And I believe I could hook one of the strings up to solar panels and the other string up to something like a wind turbine. However, after talking to GrowWatt over the phone, they did not recommend it. And I'm not exactly sure what the reasoning was behind it. We didn't get too far into it. So let's just assume that you need 2 separate inverters if you're going to have solar and wind. I think that would be a safe way to approach it. But, you know, some of these wind turbines that you can purchase off of Amazon or some other companies as well, they're pretty inexpensive. You know, you're looking at, let's say this one does 1,000 watts at 24 volts for $899. You know, if you live in an area that just, let's say for instance Seattle, and it's just cloudy 24/7, you don't see much sun, but you do get a lot of wind, perhaps you live close to the coast or something like that, you could definitely utilize wind energy to power your mining farm. But the fluctuations from solar can be, or excuse me, fluctuations from wind energy can be pretty drastic. There's going to be, let's say for instance, a minute or two at a time where it's producing 6, 7, 800 watts, and then you're going to drop down to 200 watts instantaneously. So something like this is better tied into a battery system and then converting your battery voltage into an inverter perhaps. But this is an alternative and something to consider, you know, if you're in one of those scenarios where you just simply can't do solar. I don't think installation of something like this is very difficult, but I do want you to bear in mind there is going to be probably more maintenance when it comes to wind turbines as compared to solar panels. Now, solar panels, you do need to get up there and wash off and clean them periodically. I think recommended is somewhere between 6 months to a year. But something like this, if you're in an area like me where it's extremely dirty or dusty, you could potentially run into issues with the bearings. You might have to pull this thing apart. You might have to repack bearings. I've heard that they are pretty difficult to maintain. But again, you know, when you look at the cost of these things, it's not very significant. And again, going back to your geographical location, if you're not in an area that gets much solar, something to consider. And then the last thing I want to talk to you guys about is hydropower. Now, this little device right here is a micro hydro generator. And I find this extremely intriguing. I would love to do something like this. Unfortunately, I don't live next to a river or a large body of water, but you might. And if you do, there are some companies out there that specialize in these micro systems, and they do produce a significant amount of power. This particular unit right here produces, I think, maximum of about 500 to 550 watts continuous. And this continuous meaning 24 hours a day. So a solar system, you're going to get about 6 hours a day, maybe 7 or 8 during the summer. But on average, I would say maybe about 6 hours a day of usable sunlight. And let's say, for example, if you've got 6,000 watts at 6 hours, well, you've got 36 kilowatt hours producing there. Now, something like this, you'd get about 12 kilowatt hours out of it a day, but it also cost approximately, roughly about the same price as my 7,500 watt system that you guys have seen videos on. But I think that something like this is definitely a possibility for you if you're by a river and you have access to a high point and a low point. So what I mean by that is this particular setup, it basically has an inlet for the water. And let me see if I can find a video for you guys to show you exactly what I mean here. Let me make sure my sound is off, bear with me. Okay. I'm just going to skip through this video a little bit here. As you can see, they are running pipe over the ground, and like I said, they're going from a high point to a low point. And the higher the elevation is to your lower point, the more pressure you're going to get. And the more pressure you get, the faster you can spin those turbines. So here they've got a collector, and when this water fills up here, it spills over into the collector, and then this goes downhill essentially. And it doesn't take a whole lot of water to build a significant amount of pressure over a long enough distance. Now, if you don't have the ability to run it over long distance, then you need more head pressure is what they would call it. So it could be a smaller diameter pipe with a much larger intake than they have here, and you can produce the same amount of head pressure with a large intake over a short distance, that kind of similar to having a small intake over a very long distance or a longer drop, if that makes sense. But let's go back to this guy's video here, and I wanted to show you these. They refer to them as spoons, but essentially you have these nozzles. There are 4 of them in this box, and then this impeller is connected to a stator or a generator. We'll kind of skip forward here a little bit so that you can see he's got the one inlet breaks off into these circular, or we'll just call them surrounding pipes, and then he's got valves for each nozzle, and each nozzle is spraying directly at these paddles, which in turn is spinning the turbine essentially. And he's created a nice little enclosure here. His drain system is not great in my opinion. I'll leave a link to his videos in the description below as well. And he is getting these from I believe a company called Langston. Maybe he has a link to it here. Yeah, Langston Alternative Power. And I'm trying to get in touch with Langston Alternative Power. I'd like to do a review on some of these products and get you guys some more information on them. But essentially, he can turn each one of these spray nozzles on or off and kind of regulate how much pressure is going to each one of those nozzles. So essentially, he can turn up his power or turn it down. And that's an important feature to have, because you know, this box is sitting outside in the elements 24 hours a day, and there may be times where you have high water flow, then there may be times where you have low water flow, and you need to be able to restrict each one of these spray nozzles to get what you want out of it. But again, going back to this design here, this is very similar to something that I tried in the past using a stator from a washing machine. So let me show you guys an example of what I mean here. So this is the bottom of a washing machine, right? And inside of this metal housing is a stator, okay? So you've got a piece of iron, and then you've got your copper windings wound around it. And essentially this is reverse engineering of a generator, because it's taking electricity and then moving that washer back and forth. But you can reverse engineer these things and turn them into generators. You can also take the wheels off of these electric scooters and do the same thing, and they do produce a significant amount of power. And like I said, this is something that I played around with before to see how much power I could make out of it. You can also rewire all of these windings to produce AC current, or you can change what frequency it's outputting and so forth. And if you guys aren't really familiar with how electric generators work, I'll just give you a couple of examples here. So you've got magnets with a north pole and a south pole. So this is your alternating current. When this particular piece of copper or iron or whatever it is that's spinning in the middle of these, this is a brush system where you have one that's connected to the positive, or one side of the lead, and the other side of the lead, and that creates your positive and your negative. Another example of this would be, let's take a look at another brush motor here, so maybe a little bit better example. As you pass mechanical energy through here and this thing spins, it creates your positive and your negative. And then if you take a look at a wind turbine, kind of a similar setup here. You basically got your gears turning your shaft. I think you guys get the idea. You may already know how an electric generator works, but in case you didn't, those are the basics essentially. Anyways, I'd really like to show you guys some working examples of a wind turbine and how much energy you can produce on a small scale, and then also with hydro. And if you guys want to see more content like that, leave some comments down below. Let me know, what do you want to see the most of? Is it hydro? Is it wind? Is it solar? And I'll try and do some experiments so that you guys have some more information. Anyways, that's all I got for you guys today. Sorry for the long video. Do me a favor, hit that like on your way out and hit the subscribe if you haven't already, and I'll see you in the next episode.